So today we're going to look at some special percents, percent of change, percent of error, and kind of continue with some of the work that we've already started. We've talked about turning those percents into decimals. What does that look like? And then how do we use them? Multiplying, dividing, all different ways. So let's jump in. Number one, a student scores a 65% on a test. If there were 20 total questions, how many did they get right? Okay, so there was a test and they got something out of 20. We can always express that as a fraction. We can also call this a ratio, something out of 20 compared to 20. And we know that it equals 65%. Now, we don't know what this number is, but if it was a 20 out of 20, that'd be 100%. If it was a 0 out of 20, it'd be a 0%. If it was a 10, half of 20, that's a 50%. So we can assume it's a number that's more than 10 because we got more than a 50%. But right now we don't know what it is. So you could write it out like this to represent the situation. Now we've talked about if you want to find the percent of a number, all you have to do is multiply by the decimal. So 0.65 is the decimal version of 65%. Remember, if you want to get that, you just take 65, divide by 100, and you're going to get 0.65. So if I want to know what's 65% out of 20, all I'm going to do is multiply 0.65 times 20. Now, how do these two things relate? Let's take a look. If I was trying to actually solve this and I wanted x by itself, I want to get rid of this divide by 20, so I would multiply by 20. And so I'm going to be multiplying 65% times 20. Well, 65% is 0.65. And if I'm multiplying 0.65 times 20, this is what I've got. All right, so I don't have to walk through this process every time. I can jump straight to 65% times 20. But this is what it's actually representing. Something out of 20 equals 65%. And we simplify it, so x is by itself. X would represent how many questions were right. So this is going to equal x. And we're just going to grab our calculator and we're going to multiply. So we're going to go 0.65 times 20. And x equals 13. And in this case, it asks how many did they get right. And they got 13 out of 20. Now, I could ask how many did you get wrong, and then you'd have to take the 13 and subtract it from the 20. See, what's the other piece? So that would be 7. So 7 wrong means 13 right, which is a 65%. Okay, number 2 now. I'm going to get a little tricky now. So a blender costs $13.78 after taxes. So this is not on the price tag. Okay, it's got a price on the price tag. You're going to pay that, but you're also paying sales tax, which in this case is 6%. So it's the price on the tag plus they tack on 6%. And this is what you ended up paying. So this is not what the blender costs on the price tag. This is what it costs after the taxes are tacked onto it. They're asking us to work backwards now. What did the blender cost before taxes? So most students will just go ahead and they'll multiply this by 6%. They'll find 6%, and they might even subtract it off of it. Okay, but here's the problem with that. 6% of this number is different than 6% of whatever the actual price is on the price tag. Okay, because they're going to be different numbers, so 6% of those numbers will be different. So I didn't get charged 6% of this number. I got charged 6% of whatever's on that price tag. So you've got your price tag plus 6% equals $13.78. So if I pay what's on the price tag and then 6%, that's kind of like I paid 100% and then I had to pay another 6%. 100% of the price from the price tag plus an extra 6% gave me $13.78. So I actually paid a total of 106% of whatever that price tag price was. Now, how do I represent that as a decimal? Because it's 106% of the original price. So 106 divided by 100, because every percentage is out of 100, is 1.06. So just like with our 65%, we move that decimal 2 spots. We're doing the same thing, moving it 2 spots. So this is the same as 1.06 times the price gave us $13.78. So this price, $13.78, is 106% of whatever's on that price tag. Now I want to get P by itself, so since this says times, I'm dividing by 1.06. These will go away, and that's going to leave me the price from the tag. So $13.78 divided by 1.06 comes out to $13. So you walk up in the store, the price tag says $13. Now they're going to charge you 6% of that. Okay, so 0.06 times 13 will get you the tax. 0.06 times 13. 78 cents. So you got to pay the 13 plus you got to pay the 78 cents tax. And that's where the total comes in of $13.78. So this isn't part of your work. I'm just showing you how this all works out. So they told you the end price of $13.78. It'd be a lot easier if they just said it's $13 for the shirt or the blender or whatever it is. And then you got to pay 6%. How much does it cost you? Well, then you just take 6%, you tack it on, and you're done. Working backwards, though, is going to be a little trickier. This price is 106% of the original, because the price itself, which we found out to be 13, that's the 100%. The tax is the 6%, so altogether it's 106%. That equals $13.78. So 106% of the price, divide, you get your answer. So these are going to be some of the trickier ones. We'll spend a lot of time practicing those. So if we slide down now, we're going to talk about percent of error, and then we're going to talk about percent of change. During a science experiment, Holly calculated a measurement to be 32 milliliters, but the actual answer, the correct answer, was 35 milliliters. What was her percent of error? So what a percent of error is going to tell you is how significant was the mistake or the error. So the bigger the percentage, the more significant that error was. So here's the easiest way to explain it. The correct answer was 35. She was only off by 3 compared to 35. Let's say that that answer was actually 1,000,000 and she was only off by 3 again. So she's off by 3 when the answer is 35, and she's off by 3 when the answer is 1,000,000. So which one was she actually closer to? She's off by 3 on both of them. But if it's 1,000,000 and she's only off by 3, that's pretty darn close. If it's 35 and she's off by 3, well, relatively, that's not really as close. It's kind of like thinking about if there's a sale price on an item in a store, and it's normally $10, and you get $5 off. Well, that's 50% off. That's a pretty significant deal. But what if it's a TV that's normally $1,000 and they're going to give you $5 off? You're going to say, well, that's like hardly anything. It's $1,000. You're only taking $5 off. Well, both items, the $10 and the $1,000, they gave you the same amount off, $5. But which one was more significant? The 5 off the 10 was more significant because it was 50%. The 5 off the 1,000, not as significant, very small percent. So this percent of error is going to tell you how significant is the error, and down here how significant is the change. Okay, so here's how you set these up. You put the amount of the error up top, and you put the correct answer on the bottom. So where most people mess this up is they put the actual answer that the person came up with, 32, the wrong answer. They put the actual answer on top, but it's the amount of error. How far off were you? How far off? So since the correct answer was 35 and she said 32, okay, she was off by 3. So the amount of her error was 3. How far off? 3. The correct answer was 35. So we're not actually comparing her answer to the correct answer. We're comparing the mistake, how far off she was. So think about it again like money. If this was $35 and you're going to get $3 off, how significant is that? Because if this was $10,000 and they're only going to give you $3 off, that's much less significant than $3 off of 35. Okay, so anytime we want to find the percent now, what is 3 out of 35 as a percent? You divide. It's a fraction. So 3 divided by 35. And you get this big long number. You may say, well, I must have done something wrong. But these are not always going to work out nicely. They gave you instructions on what to do if you don't get a nice decimal. Round to the nearest percent. So that means we shouldn't have a 0.6% or a 0.8%. If it's to the nearest percent, that's a whole number. So just 20%, 30%, something like that. So let's just write down some of this. 0.8571, that's enough. So we've talked about you move the decimal 2 spots, and you're going to get between the 8 and the 5. And what you're actually doing is you're timesing by 100. And so this is 8.5% basically. If I go from the calculator, 8.57%. You could go as many digits there as you want. But we want to round this to the nearest percent, or basically the nearest whole number. So this 0.5 is going to bump up the 8. So 5 and up, you bump it up. That's how you're rounding. 5 and up, bump it up. 4 and lower, you leave it the same. So this is either going to stay 8% or it's going to go up to 9%. The 5 bumps it up. So my final answer here is a 9% error. So really not that huge. 9% is not that huge. A 50% error, that would be a big mistake. Now a 2% error would be much less. So we can start to compare different types of errors. So number 4, percent of change, is the same idea. How significant is the change? So, gallon of milk, it was $3.60 last week. Now it costs $3.12. So it's much less. How much less? Let's do 360 minus 312. It's changed by 48 cents. Okay, so it's gone down 48 cents. Let's write that number and save it for later. Again, let's go back to the television. If your $1,000 television goes down in price by 48 cents, nobody cares. It's not significant. But your gallon of milk went down 48 cents, and you go, oh, sweet. That's a pretty good deal. It's gone down. So it's significant for this little number, $3.60. For $1,000, 48-cent change, not significant. Okay, so the percent is going to tell us how significant this is. Okay, so when we set these up, they're very similar to the last ones. It's the amount of change on top, so not the new price, the amount it changed, which we said was 48 cents. We're always going to express that as a positive number. Okay, so no negatives. It changed by 48 cents. Whether it went up or went down, the change was 48 cents. And we're comparing that to what it was. It was this, it changed how much? So it changed by 48 cents, 0.48, and the original price was $3.60. We're going to divide these and we're going to find out the percent of change. So 0.48 divided by 360, and we get 0.13, and then it's 3 repeated after that. Now we're going to times this by 100, which is going to move this 2 spots. So it's going to be 13.3 repeated percent. Okay, and we're again rounding to the nearest percent. So we're going to look at, it's going to be 13 or it's going to be 14%. It either bumps up to 14 or stays 13, and it's based on this number. 5 and up, bump it up. So since it's not a 5 or higher, our answer here is 4%, and then you have to specify increase or decrease. This went down. It is a decrease.